Hello, everyone. To our turbocharged extract creation and modification, a technical introduction to the HyperAPI using Python talk. That's quite a mouthful. Yeah, I hope you're still alive after Data Night Out. This is the last session of the TC, and it's our 7th session this TC on Hyper/HyperAPI. So, but let's get it. It will be very interesting. So this is a great finale for the conference. Let's get it started. First, let's start shortly with who are we. If you've been to one of our 7 talks, you already know that. I'm Jan. I'm a manager in the Hyper team. I'm with Tableau for almost 4 years now, and I was also working on Hyper before. I was also part of the initial acquisition, so I work on Hyper for like 9 years now, almost from the beginning of Hyper. Yeah, and I'm the technical manager for the HyperAPI, so I know the technical details. And with me today is Jonas.
Yeah, maybe one thing that Jan forgot to mention is that he also did his PhD in database systems. So if you have any question about databases, SQL, anything, that's the guy. Cool, so my name is Jonas. I'm a product manager for the HyperAPI. I'm also located in Munich. I'm with Tableau for about 3 years now. And yeah, I did the HyperAPI from the beginning on, from the product side, so I'm the expert for product questions about the HyperAPI. Cool, so let's come to the agenda for today. One of the main goals that we have for today is that we want to empower you to understand what the HyperAPI is and also when to use the HyperAPI. Then we will go quite a bit into the details of the HyperAPI and also about basics of the HyperAPI. Then Jan will give a walkthrough through the whole HyperAPI, explaining the important concepts of the API, how also quite some information about Hyper in general. Then we will jump into advanced scenarios. And we will have a look at advanced scenarios. And finally, we will talk about recommendations, things that we recommend you to do or not to do with the HyperAPI. And at the end, we also allocated some time for Q&A. As this is the last session for today, we can also go over time from our side. So
one question here, who of you was in one of our hands-on training sessions? Okay, quite some people. So for the ones of you, this is, in the hands-on training, we concentrated on a few scenarios. Right here, we want to be broader. There will be some overlap, but here we want to be broader because we don't need to give you time for coding, so we can tell you more about every single cool thing of the API. So you'll get a more broad overview of what the API can do.
Yeah, and we've been working on the API for quite some time now, and we're super excited about it. So let's get started. First, I want to quickly talk about our Tableau developer platform. And so we categorize our developer tools that we provide from Tableau into 5 categories, I would say. So we do have automation integration, extensibility, advanced analytics, embedding, and also data connectivity. The HyperAPI is in those 2. So I have an old slide here. The upper left should also be revealed. So it is in those 2 categories because with the HyperAPI, it is basically about automating extract creation and also like updating extracts or getting data back from extracts, and also enables you to get more data connectivity. So you can connect to data sources to which Tableau does not provide an out-of-the-box connector. So the question is now when to use the HyperAPI. And we usually say that those are the scenarios in which you want to use the HyperAPI. As I already said, when you have a data source, but Tableau does not provide an out-of-the-box connector, then you can use the HyperAPI to create an extract from the data, to create a hyperfile from the data, and publish it to Tableau, such that you can do analytics on this data. Another use case is when you have a custom ETL process. Let's say you have this custom ETL process in Python, and you're pulling in data from various data sources, doing some cleaning, and also some transformations. And then you want to integrate the output of this ETL process into Tableau. You want to be able to analyze this data into Tableau. For that, you can use the HyperAPI to create a hyperfile from this data, and then publish it to Tableau server to analyze this data. Finally, next, if you are a technology partner and are developing an application which wants to integrate with Tableau, then you can use the HyperAPI to do this integration.
You're also allowed to develop an application if you're not a technology partner.
Yeah, obviously. One example here is Alteryx. They are using the HyperAPI to use hyperfiles as inputs for their flows, and also hyperfiles as outputs for the flows. And finally, if you just need flexibility in your advanced BI scenarios, let's say you want to implement a complex incremental refresh or complex incremental updates on your hyperfiles. In this case, you can use the HyperAPI to do that.
Yeah. In the hands-on training, we had the rolling window where you delete old data and insert new data. That's currently only possible with the HyperAPI.
Okay. So let me quickly talk about the evolution of the HyperAPI. Because as many of you know, there was the Tableau SDK and also the Extract API 2.0 before, right? But the difference here is both of these APIs enabled you to create TDE files or hyperfiles, right? But it was only about creation. And when talking to customers, we oftentimes heard that they need more flexibility. They also want to update data in hyperfiles. They don't want to recreate this hyperfile all the time. Or they want to read back data from this hyperfile. And this is why we implemented the new HyperAPI. Because apart from creating extracts, it also enables you to read data back from extracts, to update data in extracts, and also
delete, update, read, CRUD.
CRUD, yeah.
Create, read, update, delete.
To execute CRUD operations on extracts. And apart from that, we also improved the performance of extract creation by a lot for the new HyperAPI, and also enable you to directly create extracts from CSV files.
And also quality-wise, it's a totally different thing, right? Because HyperAPI and Tableau SDK, they were always like, yeah, pet projects, not well maintained. HyperAPI had exactly 0 test cases. But with HyperAPI, we use HyperAPI in Tableau. So Tableau uses HyperAPI to interact with Hyper. So this is really a thing we use in our own products. So the quality should also be way higher than the old APIs. Also, Prep uses it, all our products.
Cool, Jan.
All right. Now let's get started with the basics. To recap, because why is it called HyperAPI? Well, because it interacts with Hyper. What is Hyper? Hyper is Tableau's next generation general purpose data engine or database system. It's SQL-based, it's highly scalable, and it's optimized for hybrid workloads. That's an especially cool thing about it. So it can theoretically and also practically do updates and analytics at the same time on the same state of data. The big picture of the HyperAPI looks like this. HyperAPI is an API, right? So you write code, you have your application or your script. There you have your client code, that's your code that interacts with the HyperAPI. It interacts with the HyperAPI front end. That's the part of the API which we ship in 4 different languages. And this front end interacts with the back end, which is a shared library. It's a shared library because it has to be very fast, right? The heavy lifting is all done by the back end. and you don't want to write that in Python. So therefore, it's a shared library, machine code, highly optimized. And this backend creates and then communicates with a hyper process. That's our hyper database engine. That's exactly the same hyper database engine that's also used by Tableau and Prep. The HyperAPI spins it up itself, and then you can connect to it through SQL. It allows you SQL connections, and then through Hyper, you connect to these hyper files. For us, a hyper file is just a database. So whenever I use the term database, just think of it, it is a hyper file, and therefore it's also an extract. An extract is exactly the same thing for Hyper as a database. You can have multiple hyper files or databases or extracts attached to the same connection. Then you can do stuff like moving data between them, joining between them. Jonas will talk about this later. You can also have multiple SQL connections, so you can do multiple things at the same time. You could also create multiple hyper processes, but we advise you to not do it because they will contend for resources. One hyper process is enough to, even if you have a 100-core machine, one hyper process can leverage all of them. What is HyperAPI and what it is not? This slide is in here because a lot of customers ask, okay, how do I use it to create a data source? How do I use it to publish a data source to Tableau server? The answer is you don't, because it's not made for that. We have other APIs for that. But HyperAPI is only there for the creation, read, and update of local hyperfiles. That means local on your machine where you execute your script. That means it does not need any other Tableau product installed. It does not interact with any other Tableau product, and especially it does not interact with Tableau server. And therefore, it does not allow uploading, accessing, or downloading extracts from Tableau server.
So one important thing to mention here is like a hyper file. So that means when we do extract creation with the HyperAPI, we create a hyper file. And in this hyper file, there's data in there. This data can then be published to Tableau server. But the information, how you got this data in there, it's not in this file, right? Because you did it programmatically. In Tableau, when you switch from live to extract, then this information, from where does this extract come? This information is preserved and then published to Tableau server. This is why you can then add this on a refresh schedule, for example. Yeah. Right? Because this connection to where does this data come from is still there. However, when you create a hyper file programmatically, this information does not exist. So that means it's your job
to refresh it.
To refresh.
You can refresh. What should server do when you hit refresh? It doesn't know how it was created. So you create it. When you run your script to republish it, that's the refresh. All right. Now, time to wake up for everyone who was in our hands-on training sessions, because until now the slides were more or less the same. Now it gets different. Now we want to get a bit more into the structure of hyperfiles. As we said, Hyper are SQL databases. Inside hyperfiles, we have schemas. Schemas, think of them as just namespaces. And inside of schemas, we have tables. So in this hyperfile, we have a schema X and a table. In schema X, we have table A and B. We could have another schema Y with a table C. We could also have in schema Y, we could also have a table A. As they reside in different namespaces, they can have the same name, and it's still different tables. A usual single table extract, as it is created by Tableau. So if in Tableau you go from live to extract, you get a hyperfile. And this is how it looks like. It has exactly one schema called extract, and in this schema called extract, it has a table called extract. That's also why we in the hands-on training session tried to create exactly that, because that's what Tableau creates. A newly created database file looks like this. In the hands-on training, we said, yeah, it has no schema. That's not true. It has a schema called public. Why is that? Because that's also what Postgres does, and we try to be Postgres compatible. But that means in the hands-on training, we had to first create the schema extract, right? Because you see, in a newly created database, there's no schema named extract. This is the structure of hyperfiles. And you see hyperfiles can have multiple tables. The default case is just one table, but you can absolutely, with the HyperAPI, create multi-table extracts. It's just harder to publish these to Tableau server because you need a data source description. If you have questions about that, let's postpone that to the Q&A, because that's a deep rat hole. Okay, HyperAPI, Hello World. In the hands-on training, you already saw it. Just a quick walkthrough. How do you do Hello World in Hyper? You have imports in Python. Then you start this Hyper process. With the Hyper process, you can enable or disable telemetry. We advise you to please enable it so Tableau gets your usage data. We don't send your personal data. We don't send the data you insert, but usage data like how long did your queries take, do you insert, delete, stuff like that. So we can optimize the API in the future better to your use cases. So please enable it. Oh yeah, here it is. Then we can open a connection and connect to a database. In this case, here we connect to Hello World database. And then we can execute SQL on it, right? Here we can just execute a SQL that just queries a constant because there's no table in this extract yet. But this is Hello World and HyperAPI. You see, there are always these two lines, creating a Hyper process and then connecting to it. Yeah, now, in the hands-on training, we only went through Python because most people also use Python. That's also where we have most downloads right now. But if you ever consider switching to another language, the cool thing is we try to design all languages to be very similar. So all languages have the same features, have the same class names, function names. So the hyperprocess class also in the Java version and the C++ version is also called hyperprocess. And its constructor takes the same parameters. However, we also tried to stay idiomatic, right? Because in different languages, there are different idioms how nice code looks like, and we also tried to be like that. So we just didn't auto-generate all languages and then it all feels like Python, even though it's C++. No, we tried to make that it feels natural to the languages. What can I do with a connection to a hyperfile? Now it gets really broad, like what can we really do with it? First, we can do data ingestion. And here you see I have two different colors. How you can do it. We have this turquoise color. That means there's a high-level API. That means there's a class for that. There's a class for creating tables. You don't need SQL. But some advanced scenarios, you need SQL. For example, here, you can create tables and define columns. You can insert and append rows to a table. That can be done through classes. You can also do bulk insertion from CSV into the table, but for that, you need a SQL statement. But that's really fast. So if you have CSV data, consider doing that. It's way faster than reading the CSV data yourself and trying to insert it. And it's also less code. It's just one line. Hey, here's a CSV file. Please put it into the table. Thanks. You can update, delete. We saw that in the hands-on training, but you need SQL for that. Update, just an update statement in SQL. Delete statement. You can also delete whole tables, delete whole schemas, delete databases. Well, but that's just deleting the file. But you can do a lot.
One thing that you did not mention, which you can also do, is you can also change the schema of a table, meaning you can add columns to a table or also delete columns from the table.
That's true, yeah. You can also read data, so you can scan a table. This is a totally new thing, right? Until now, extracts were data sinks. The only thing you could do with them was visualize them in Tableau. There was no way to get the data out of it. This with Hyper has ended. Now you can really also use extracts to read data from them and do whatever you want to do with that data.
We will show at the end, or later on, we will show some interesting use cases which use reading from Hyper files.
Yeah. What you can also do, easiest SQL is just select star from table, right? That gives you all the rows and you can do something with it. But we also do support complex SQL queries on one or multiple tables, or even on one or multiple databases. You can join between databases, because think of it, it's the backend of Tableau. And when you have a complex wiz, the SQL that Tableau sends can be humongous. We had seen SQL queries that are like 40 megabytes of SQL text. That's a whole bookshelf full of SQL text just for one query, and Hyper processes these. So Hyper is pretty good at really crunching through complex SQL. So do whatever you can. You as a human can never write as complex queries as Tableau can. You can also, this was reading data, but you can also read metadata. You can ask, for example, what schemas and what tables are in this file. For example, if you have a file that becomes more important with like multi-table extract, right? Because with one table, it's not very interesting. Yeah, there's one table called extract. Thank you. But with multi-table, you can ask, okay, which tables are there? How do they look like? How do the columns look like? What are the types? So you can reason about the structure of your database file. For example, we had one thing which Jonas will cover later. You could search in all text columns in all your extracts, no matter how the table is named or how the column is named. Search all text columns, for example, for social security numbers, right? You have some sorry, but if you have some audit going on, someone's telling you, hey, you have to remove all social security number from your extracts. It's private data. Just search on it everywhere on your server, right? Not on the server. You have to download it first. Sorry. Okay, one slide. How do you get HyperAPI knowledge, right? Because this is a theoretical talk. We already gave some hands-on sessions. But if you need more information, we have in the HyperAPI package, when you download it, there are already examples inside. Currently 5 examples. We might add new ones based on interest in future releases. First one is inserting data into a single table. That's the most basic use case. Inserting data into multiple tables, deleting rows from a table, updating rows in a table, and reading from a table. That's currently what we ship as examples with the HyperAPI. We have a SQL reference documentation, which I'll show you in a bit. And of course, also a documentation for all the languages. And of course, we have the sessions at TC, but well, this is our last one, so sorry. You could go back in time, though, and do the hands-on check. Whatever. You can talk to us at the Tableau showcase, but that's the last. When we made these slides, we didn't know we get the last slot of the whole conference, right? So not sure if the booth in Tableau showcase is still manned. But what you can do, you can go to the Tableau developer forums, ask your questions there. If you join our developer program, there's also a Slack channel, so there are ways to interact with our developers. Or you can just ask on Stack Overflow. We are developers, so we are on Stack Overflow anyway every day. So just ask there. So there are ways to really talk to our developers and get technical help. Yeah. Okay, now a quick documentation of where to get HyperAPI and the documentation. Quick answer, it's tabsoft.co, HyperAPI. But you can also just Google it. I think it should be more or less the first hit on Google if you Google Tableau HyperAPI. This is how the page looks like. First thing, we were asked before, what license do I need for it? The answer is it's a free download. Okay, so you can just download it from this website. You don't even need to sign in. You can just download it. That's as simple as it can get. We're even planning, yeah.
There's still the license agreement.
There's some kind of license agreement as with every product, but the gist is it's free. We also plan at some point to, for example, the Python version to put it on PyPy, so at some point in the future you might even just type pip install Tableau HyperAPI and you're done. We're not there yet, so for now you have to download it from this page. And there's also the documentation, API reference. We have our SQL documentation, and then for the different languages we have documentation. And just to show you one example that really Hyper can do a lot of SQL, even though, excuse us, because until now, HyperSQL was not publicly available, so we never wrote a documentation. So this documentation is brand new, and it's still a bit of beta. So it might be that there are things not in there which actually work, but we just didn't have time to
document
them.
Our strategy here is everything that we document here publicly is supported.
Yeah. But you see there's already some stuff.
Modulo defects if we
creating a database, creating a table, and for example, to show you that there's really some analytics in there. If you hit the select statement, that's the select statement. Can I make it bigger? Yeah, I can. You see select distinct from where group by having window clauses are supported, order by, limit, offset, fetch, whatever. You see joins, and even more joins. A lot of SQL is supported. All right. That's about the documentation. Now a short walkthrough. Yes? Oh, a window clause. It allows you to reason over other rows in your data set. For example, you could say, okay, first order my rows by date, and now I want to get the average of the last 3 dates before my date. So I say like, okay, give me all rows that were 3 days before mine and calculate the average of these. Things like very, very powerful, but also not super easy to use, but very powerful, and it would be really hard to express that without window functions. You could do it with complex joins, but it would take way longer, and yeah. Okay, now a little walkthrough just to show you what features are there. We will walk you through using 2 scenarios. Well, first we go over basics. That's not a scenario. Name, data types, that's very interesting also for the people that were in the hot sessions, because we had not much time to cover that in the hot session. Hopefully now you'll get a better understanding. And then we do extract creation, create an extract, define, create the table, insert data, and then do the more advanced stuff, updating, SQL, querying, and finally ingesting CSV. Ingesting CSV was not in the hands-on training, so you learned something new. Okay, let's go to the basics. First thing, names in SQL. Unqualified versus qualified. A database, so a hyperfile, can contain multiple schemas that have a table with the same name, right? In this case, you see there's the table Z, which is in Y1 and in Y2. That absolutely works. And if you now type select star from Z, which table is it? The answer is it doesn't work. It will say like, that's ambiguous. The solution is you have to qualify the name. You have to say y1.z. Then it knows, okay, you mean table Z in schema Y1. You can even qualify it further with the database, because we said you can connect multiple databases to the same connection. So it could be that there's another database that also has a schema Y1 with table Z. Right? So you can further qualify it. So if your file is named x.hyper, then we by default aliases with the name, so with a stem, that's the technical term for it. So just get rid of the .hyper. In this case, it's x. So you could say x.y1.z, which means table Z in schema Y1 in database X. It's only necessary if you have multiple databases, because otherwise it's always the one database you have connected to.
A good example of a scenario would be, let's say you have twice the same hyperfile with the same schema, but with different data in there. And that way, that means the schema and the table name would be the same, but you want to union this data, right, into a third one. Yeah. Then you need to fully qualify database name, schema name, and table name, otherwise.
Yeah, or for example, you have 2 versions of the same file that you created at different dates, and you want to see what are the differences. You want to do a set difference, and then, of course, they will have the same schema. Next thing, I saw this in the hot session. Never use raw names in SQL strings. You know this thing called SQL injection? It's error-prone. Well, SQL injection is not error-prone. SQL injection is a result of escaping being error-prone. Escaping means you have to escape if there are like spaces in it. You have to escape it with a backslash. You have to wrap some quotes around it. You have to use the correct quotes, stuff like that. And that opens the door to SQL injection, right? If you take user data as a name and say, hey, please, user, give me a name, and the user write, yeah, my table is named, delete star from drop database foo, yeah? Then this will be executed, so don't do this. HyperAPI has classes to handle names. The most important classes are the name class, that's an escaped unqualified name, and the table name. We use that in the hands-on training. That's an escaped table name, which optionally is qualified with the schema and schema database. And now it makes sense maybe to you that in the hands-on training we had this extract, comma, extract, right? That's a table name extract that's qualified with a schema extract. And yeah.
I just wanted to say that means when you're writing an application, just use those classes to reference tables or just names in general.
Here it is. Always use these classes. So you see, like in Python, that's now Python code. Instead of saying like, yeah, the table is named extract.extract, use inside the string the table name extract class. And when this class then is inserted into the string, it will just magically do everything correctly, and you cannot. It disables SQL injection. Nothing bad can happen. For example, also names are case sensitive, so we used extract with a capital E. It has to be capital, otherwise, or at least it has to match everywhere. Data types. Okay, what data types do we have in Hyper? Our data types in Hyper are very standard SQL data types, which means they are not 100% the same data types as Tableau has, because Tableau is more for the end user that does not care so much about tedious differences between types. In Hyper, we are more low level, so we provide you some more types to give you better control. First, we have numeric data types, small int, integer, big int, numeric, and double. So you already see that's a bit more in Tableau. There's no difference between a small integer and a big integer. It's just a number, right? Then we have text data. There we have the data types text, varchar, and char. And you see varchar and char are red. That means never use them. Always use text. We just have varchar and char because the SQL standard says, yeah, there needs to be a type varchar and a type char. But they doesn't, in modern database systems, they don't make sense because you have to limit them. It's varchar 100, and then someone tries to insert something that's 101, and it gets truncated. Why? We have enough memory, so just use text. That means it can be as long as you want. Always use text. They're also not faster. In old databases, they were there because it's fast to limit it to 100 characters. No, that no longer holds. Text will never be slower than char or varchar. Date time, we have date, which is a date, like today. We have time, like 2 o'clock. Timestamp, that's a date plus a time, today at 2 o'clock or Monday at 3 o'clock. And we have interval, that's a time interval, like 3 hours and 20 seconds. For example, you could add an interval to a time. You could say now plus 3 hours, that's like 5 o'clock. Finally, we have some other types. You also know them. Booleans, true or false. We have bytes, which is just binary data. You can just add random binary data. Of course, you already see we give you very raw access because binary data you can't visualize, right? It's just, it could be a JPEG or whatever you put in there. But this is just for, you can read it out and do something with it. And we have geography. That's our Tableau geography type, and some more types. But these are the most important ones. Okay. How do I now do the connection management and database creation? I will just gloss over it quickly because it was already in the Hello World example. You first create a Hyper process and then you create a connection. It's easy as that. Now we're connected to a Hyper file. What can we do? We can define and create a table. We had this also in the hands-on training. This is how do you define a table. First you give it a name. Here in this case it's qualified with a schema, extract, extract. And you give it some columns, right? In this case, 4 columns. Each column has a name, a data type, and whether it's nullable or not. You know that from SQL. You have this, whether a field can be null. Null means something like unknown. And sometimes it makes sense that you can have unknown values, and sometimes it doesn't make sense, so you can say that.
And maybe one addition here is that this is a convenience method to create a table, because what you could always do is just write a SQL statement, create table, extract.extract, customer ID, text, and so on, right?
So the thing is, under the hood, HyperAPI always sends SQL to Hyper. All the classes that we provide to you just make you the SQL, they create SQL under the hood and send it to Hyper. So with Hyper, we just talk SQL. And then you have to create this table here. We also had that in the hands-on training, right? We first define it, and then you say, OK, please create me this table. And now inserting data. We had this in the hands-on training. With inserter, you create an inserter class, you add rows, and then you say execute. Please do this insertion. Don't forget the execute, otherwise your data will not be inserted. So if you ever use the inserter and then open your extract and it's empty, you probably forgot calling execute. And before you use your file, please remember to close the connection. Because as long as you have a connection to the Hyper file, Hyper still owns that file, right? So when you try to move it or try to open it in Tableau Desktop, you will get an error, oh, this file is opened by another process, right? But by closing the connection, you release everything. You also make sure that all updates are written to the file. So after you close your connection, you can use the file. Updating a table within SQL. We also have that in the hands-on training. Just use SQL. Use the update statement. Here, for example, we say, like, OK, in our customer table, give someone more loyalty points. Set the loyalty points. Oh, there's something missing. It should be set loyalty points equals loyalty points plus 1,000, where, well, customer DK13375, he just received 1,000 loyalty points. Nice. Querying a table is just execute a list query, select star from. Here in this case, execute list query means the result that we get is a list of rows.
And this is a function that we only provide in Python, right?
Yeah, that's a function we only provide in Python because in other languages there is not such a concept as row lists. Well, there are other data structures, but they are strongly typed, so it's way harder. So that's a convenience method in Python, and it's good for small results because it provides you the whole result as a list, right? So for small results, it's good. But if you query 1 billion rows, you don't want these 1 billion rows in your memory at a time, right? So what you can do then is execute query. You already see that method somehow looks, the name sounds more like, okay, that's a real deal. There you get a result, and the result is an iterator, which will just load the next rows in memory. So even if you query 1 billion, 1 trillion rows, whatever, it will not overflow your memory because it will only just get the next rows, and once you read them, it will get the rows after that. You can just iterate over that iterator, and for example, in this case, print the rows. You can, for example, print the whole row or get different values at different positions. So you see, we give you very much flexibility of how to retrieve your results. Yeah, as I said that. Yeah, and of course, other languages only have that method. In other languages, you just get a result. You also know this from other database API like JDBC, ODBC. You just get an iterator, right?
Yeah, I think we have execute query and execute command. So if you're an execute Scala.
Yeah, we also have execute Scala query. That is just, it returns a single result. That's also pretty cool if you just know, you just select count star from table. That just returns you one integer. There you say execute Scala query, and you just get that single result. You don't get a list of a single list with a single column with an integer in it. You just get the integer. It's way simpler. It's just a convenience method.
Yeah, and command just returns you the number of rows affected, right?
Command we had before, like here for update, we said execute command. We could have also said execute query, then we would have gotten the result of an update command, but it doesn't have a result, so we would have gotten an empty result. Command returns you the update count. So this would return how many rows were updated. So you see there are various methods you can use. You can also do more complex SQL. This is just a surrogate. I want to show you you can do count star, group by, order by, whatever. Get as crazy as you want. Hyper can handle very complex SQL. Ingesting CSV data, that's a new thing that we didn't show you before, but it's also in our examples. So Hyper has direct support for reading CSV data. There's just a copy command where you say like, okay, please copy me into this table, customer table, from a CSV file, and you give it some more parameters like, oh, it's a CSV file. The null value is represented by the string null. The delimiter is a comma, so you can also use another delimiter, tab or pipe or whatever. And the cool thing about is that then Hyper directly reads the CSV file. It doesn't go through your Python. Python is dropped that slow, but this will just tell Hyper, hey, please read the CSV file. And this is very fast. One customer already tried it. He got like 120 megabytes per second reading. And yeah, think about it. That's way faster usually than you can get with the insert, and it's way faster than you also can get in Tableau or in prep when reading the CSV file. So if you have CSV data, use that. It will not get faster than that.
Yeah, so this scenario was already possible with both the Tableau SDK and the Extract API 2, but you would have to write an application which reads from the CSV file and then inserts it. Now, let just Hyper do the heavy lifting.
Yeah. And it might even, it's not even parallelized yet. So this 126 megabytes, Hyper does that with a single thread. We might parallelize it in the future, then you'll get gigabytes per second read speed. Then it's really just limited by a disk, even if you have a very fast disk. Okay, exploring an extract. So far we always knew, okay, I can create this table, I can query that table. What if you get an extract? You just scrape extracts of your Tableau server and you don't know what they are about, you want to explore them. That you can do with the catalog. It can just, you have queries, metadata. Now we're about querying metadata. We have a catalog object that gives you access to metadata. For example, you can ask it like, hey, please give me all table names in the schema public or in the schema extract or whatever. and it will list you all the table names in there. What we can then do, okay, we iterate over these names, and for each one we tell the catalog, okay, now for this table with that name, please give me the definition. I want the definition, I want to know which columns are in there. For example, yeah, here we first write the name, and then now we have the definition, we have the columns, now we iterate over the columns. And we print, for example, here the column has this type and this nullability information. So with these 4 lines of code, we could already have a program which on the command line prints you, hey, how do the tables in this extract look like? You see, it's all very simple and very powerful. And with that, I give it to Jonas. He will talk about more advanced scenarios. That was basically the whole simple structure of the API. You see, it's not much. I was able to explain it to you in like 15 minutes. It's not that much, but it's very powerful.
Let's say 20 minutes.
20 minutes, all right.
Cool. Okay, so I have 3 scenarios for you today. 2 of them, we call them cross-DB scenarios, meaning you're connecting to more than one hyperfile at a time. And the third one, this is what Jan already spoiled.
Sorry.
It's about searching PII information in multiple hyperfiles, right? So first of all, let's say my use case is the following. I want to join. I've let's say 2 hyperfiles, right here, x1 and x2, and I want to join the data from those 2 hyperfiles. So how do I do this? And that's really nice, because what you can do is when you have a connection, you can attach databases to a connection. So you can see here in this connection.catalog attach database x1.hyper and x2.hyper. This will attach those 2 databases to Hyper. Means now you can query data from it. But what's important now is that you are very careful with the naming, because now you need to properly name things. And this is why we have this 3rd parameter in this table name class, right? We have x1, which is the hyperfile. Then we have y1, which is the namespace in this hyperfile. And then, schema, thank you. And then we have set1, which is the table. Okay, so what we do here is we select everything from this one table, join it, joined with the other table on the column set1 foo, and set2 bar.
I think there's one join too much. It should be join table name on and not join on. Join.
Yeah.
Sorry.
My bad.
What you also see here is that in our initial connection statement on top, we don't connect to a database. We say, hey, please connect to nothing, right? Because then afterwards we attach the database. That's also possible. So what you did in the hands-on training, that you directly connected to a database, it's just a convenience way for first connecting to nothing and then attaching the database.
It's also very handy when you're attaching a database, you can give it an alias. Because otherwise it would take the stem, so everything which is in front of .hyper, right? But if you have a super long name, you can also just give it an alias A.
Or it could even be you have 2 extracts that have the same file name but are just in different directories, and if you don't give it an alias, Hyper would say, I already have that database, but you can give it alias and therefore have 2 files with the same name. But that's not in this code. You would just add a second parameter to the attached database statement saying giving it the alias.
Just coming with a microphone.
Yeah. The question was probably how do you do that with the alias? You add another parameter to the attached statement.
Okay. Next cross-DB use case. It is kind of similar, but it shows that you can also what does it show? It shows a nice SQL statement. This create table as.
You can reveal it. Oh.
Yes, we can reveal it. And this is basically a use case. Let's say you have multiple hyperfiles, and you want to union all of these hyperfiles into one hyperfile in order to analyze it in Tableau, let's say. Yeah. This is what we heard from customers quite often. So how do you do it?
We had, for example, one customer that creates a hyper extract for every day, and then they want to, and now they have 1,000 extracts of the last 3 years, and they want one big extract of that. That could be done with that.
Yes. So how to do this, right? First of all, what we do here, so what do we want to do? We want to create x3.hyper, which then shall contain all the data of x1, of table set1 of the x1 hyperfile, and table set2 of x2 hyperfile. It's a little complicated from the naming. But so what we're doing in this connection statement, we connect to a database x3.hyper and create it. Even if it already exists, we override it, right? And then we are attaching the other two databases. And now what we do is we create the table in database x3 in the public namespace. And this table is named set3. And we use this create table as SQL construct, which automatically creates the table according to the schema that is in the following
query.
Select query, right? And there we say, just select everything from set1, from file x1, and union it with everything from set2, from hyperfile x2. And so one precondition here is obviously that the schema of both tables are the same. Otherwise, we would get an error from Hyper saying, hey, the schemas don't match.
What this shows you is that SQL is very powerful, right? For example, here we didn't have to create this table definition thing. We just said, okay, please create the table and use the schema that the other tables have. Why would we don't have to tell it again, right? So that's very powerful and also very effective, right? You could, the first thing you might do is, oh, I could just read the data and use the inserter to insert it. Read it from both, insert it with the inserter. But that would be way slower because you go through your client. This is one SQL statement that's done by Hyper. It will be way faster.
Cool. So finally, I will keep this super short because we want to also have some time for questions at the end. Searching for regex. For example, let's say you want to understand does your extract at hand contain PII, so personally identifiable information? Because of GDPR in Europe, you're required to delete all PII, right?
Or at least be aware about it, that you haven't.
Exactly. But you have so many extracts lying, hyperfiles lying around, and you don't know whether there is PII in. What I heard was someone wanted to just inspect the column names and then say, yeah, this sounds like PII information, so we should better look at it. Because if you have thousands of hyperfiles, how to do this? And now you have the, how to do this? Question. What you could do is you could code this in Tableau. But here, as you see, I need to do this explicitly on each of the fields, right? And then I can execute a regex on that and then see whether it is whether it matches or not. Right? However, that means I have to write all of this in Tableau and for each of each file. And if the schema doesn't match, then it doesn't work, right? With a HyperAPI, you can do this. And what I put on here is a screenshot of our help, because the Hyper SQL dialect has this tilde. Is it called tilde? Operator, right? And this tilde operator matches regexes, right? And what you can see here is basically the documentation of that. We have this example, searching for regex, in a hyperfile in our second hands-on training, which that means the code will also be available online. You can, I think, starting from Tuesday, you can find it online.
Yeah, and you see two things here. First, Hyper has a powerful set of operations, right? It has to, because it's a backend of Tableau, so everything you can express in a calc also has to be somehow be able to be done by Hyper. And the second thing is what Jonas mentioned is that you are able to query the schema, you are able to ask which columns are there, so you can dynamically build a SQL string searching in all these columns. That's what not possible in Tableau, saying like this dynamic calc that somehow works on all columns. With HyperAPI, you can do that.
Yeah, that's a good point. Cool. So I would say we now quickly go over the recommendations and then go directly into
yeah,
Q&A
it's pretty quick. Just some recommendations. Now, when you work with HyperAPI, what should you do? First, performance. If you say like, oh, I want to use HyperAPI to speed up my extract creation scenarios, good idea. It's probably very fast, but think about the language, right? What you see here is some benchmark. I think it's extract creation between the languages. And here, more is better, right?
Yes.
That's, I think, megabytes per second ingestion speed.
Yeah, but this is a very particular use case. So the idea of this image is basically to show you not the values that are here, but
the values are not interesting, but just the size of the bars. You see, first on the left 3 bars is the old extract API. So the first thing you see is, yay, HyperAPI is way faster than our old extract API. Next, the colors are the programming languages. Blue is C++, orange is C#. We didn't have it with the old API, so there's only one orange bar. Red is Java, and this turquoise thing is Python. So you see Python is 1 order of magnitude slower than C++ and Java.
Yeah. So with the new HyperAPI, we also improved the performance across the board. However, if you're really working on a if performance matters a lot for you, go for C++.
Or Java, yeah. The thing is just, but for your usual scripting with like, it's still very fast, right? Even if you have 100,000 rows, Python will still be fine. But once you go in the millions of rows, 100 million rows, maybe no longer Python, right? Or if you want to do Python, for example, if you have CSV data, use this copy thing, because we said this circumvents Python, it just lets Hyper do all the heavy lifting. Then, of course, Python is as fast as C++ because they don't do anything, they just send a SQL command to Hyper. Next thing about performance, this is a general advice not only for HyperAPI, but also for Tableau. The first one is not for Tableau. Think about the programming language, as we said. Next thing, use text for any string. Never use char or varchar, I said that. There's no performance gain in using varchar. Even if you know, oh, my string is never going to be longer than 10 characters, you gain nothing by saying varchar 10. Next thing, that's very, very, very important. When you have numeric data, use a numeric data type. If you have integers, use integer. If you have dates, use dates. What most people do is, yeah, I get it from Excel, and Excel gives me strings, so it's a string, right? It's a text. And then they start using string functions to do date calculations. Well, how do I add a year? I somehow extract the last 4 characters, that might be the year, and then I cast it to integer, add 1, cast it back to string, slap it back together. Oh God, it's horrible. That costs performance. String operations are always very slow. Instead, use date and use, as I said, there's an interval type. There's an interval type where you can just say, please add me 3 years. That's a calculation which your CPU can do in like 1 or 2 cycles. The whole string thing, 10,000, 20,000 cycles, that's really orders of magnitude slower. And that's what we see often because, of course, it is tempting. Usually you get the data from Excel or from PDF. You always get it as strings. Yeah, and then you just keep it that way. But take the time. What I wrote here, don't defer data prep to viz load time. Prep ahead of time when creating your extracts. Choose the right data types, then your viz loading will be way faster. And last thing, if you don't know what collations are, that's good. Keep it that way. Don't use them. Problem is Tableau uses them by default, but now you have HyperAPI, and you are the master of whether you use collations or not. Don't use them. Everything's good. They just cost performance, and you likely won't need them. And as we said, use this copy from CSV. Don't write CSV reading by yourself. This copy from CSV, but only if you have CSV data, right? Don't put your data into CSV first to use then this, no. But if you have CSV data, use that. And this is so far, thank you. We now have questions, open for questions, but please also complete the survey for this talk.
Thank you very much.